Okay, so what if I told you that your body isn't just a collection of cells and chemical reactions? What if it's actually a finely tuned symphony of electromagnetic receivers? In this explainer, we're diving into a book called Biological Antenna to the Humanoid Bot, and it presents a pretty radical way of looking at our own biology. It suggests we are all deeply, fundamentally connected to a world of vibration and frequency. Now, you might expect a science book to start with a dense equation, right? But this one starts with a philosophical idea from Hindu philosophy that everything, and I mean everything, at its very core is vibration. And this isn't just some poetic thought. It's the actual foundation for the biophysical model we're about to explore, one that could totally change how we see life itself. So how does this ancient idea translate into modern science?
Well, let's make that jump from philosophy to physics. The book basically argues that if we really want to understand how our bodies work, we need a major shift in perspective. We have to start thinking less about biology as a purely chemical machine and more as an electrical one, an organism that operates on a hidden language of resonance and frequency.
And this slide really nails that contrast. On the left, you've got the biology most of us learned about in school, right? A world of molecules, ion channels, kind of like complex plumbing and wiring. But on the right, that's the book's view, a dynamic system of electromagnetic resonance, where our very own components act like these tiny vibrating clocks, all ticking away in perfect harmony.
So if our body is this incredible electrical system, how does it send and receive signals? Well, this is where we get to the book's central idea. It proposes that our fundamental biological building blocks are, for all intents and purposes, antennas. They're literally designed to receive and transmit information using electromagnetic waves.
The book uses this term biomaterials when it's talking about the very stuff we're made of, DNA, RNA, proteins, but it sees them in a whole new light, not as static building blocks, but as complex resonators. You can almost imagine them as a two-part system. There's a cavity that can trap a signal, and then there's a dielectric material that vibrates when it gets hit with that signal.
Here you can see exactly how they think it works. See, the cavity part traps electromagnetic energy of a very specific frequency, and the dielectric part, that's the actual biological matter, it resonates, it vibrates in response. It's this whole two-part system that's designed to be incredibly sensitive to specific frequencies, almost like a tiny organic radio receiver.
And here are some of those antennas in action. I mean, you recognize these shapes, right? The famous double helix of DNA, the cylindrical structure of a microtubule. The book argues that these helical shapes are absolutely not an accident. Their physical form is pretty much ideal for interacting with electromagnetic fields. They are, in essence, perfect natural antennas.
So, if our cells have antennas, what language are they even speaking? Well, that language is resonance. Think about it like a radio. You could tune your car radio to 98.5 FM, but it won't pick up 102.1 FM. The book says it's the same with our bodies. Each biological component is precisely tuned to resonate with very specific frequencies, and that's how they can all communicate without getting their signals crossed.
And look, this isn't just a theory. As you can see in this table, researchers have actually measured the resonance frequencies of different protein complexes. And notice how specific they are. The SARS coronavirus complex resonates at 4.8 terahertz, while another complex is way up at 7.5. Each one has its own unique broadcast frequency, which allows for incredibly precise, targeted communication inside the body.
The authors have this really cool name for this rhythmic pulsing. They call it clocking. Because it's not just random vibration, it's a timed, periodic rhythm, just like the ticking of a clock. And the book proposes that this very clocking is the foundation of how biological systems process information. It's like a universal rhythmic language that all of our cells share.
Here's what that clocking actually looks like. What you're seeing here are the magnetic and electric fields around a tubulin protein, and they're switching on and off in a perfect repeating cycle. That's the tick-tock of a single biological clock. Now, multiply that by trillions, and you start to get the symphony of the human body.
Okay, so we've established this picture of the body as this incredibly delicate, complex system of biological radios, all communicating through very specific frequencies. But we don't live in an electromagnetically silent world, do we? Not even close. Our world is flooded with man-made signals, and this is where the two worlds collide.
And this, right here, is the crucial question the book raises. If our bodies are speaking this quiet, subtle language of resonance,
What happens when a much louder, artificial signal starts broadcasting on very similar airwaves? What happens then?
So here's the key point, the potential for interference. Our body's natural signals, they operate in the super high-frequency terahertz range. But our technology, Wi-Fi, cell phones, they broadcast in the much lower megahertz and gigahertz range. So how could they possibly interfere? Well, the book argues that structures like our DNA act as fractal antennas, and what that means is that they're capable of interacting with a huge range of frequencies, including those coming from our wireless devices.
And this is where things get serious. This potential for interference leads the authors to a very, very stark conclusion. Based on their entire model of the body as an electromagnetic system, they issue a pretty serious warning about the environment that we've all created for ourselves.
Yeah, the book does not pull any punches here. It states pretty explicitly that the radiation from wireless devices is not benign. It directly connects this constant exposure to some of the most serious health issues we're facing today, from neurological diseases like Alzheimer's and Parkinson's, all the way to genetic damage and an increased risk of cancer. The argument is that these artificial signals can seriously disrupt our body's delicate electromagnetic communications.
So what's the final word? The book's final take on the matter is completely unambiguous. After laying out this whole biophysical model, the author's recommendation is stated in the plainest possible terms. It just says, we should avoid utilizing wireless devices. That's it. It's a direct, powerful, and frankly pretty shocking conclusion to their argument.
So we're left with this final, really profound question. This book asks us to see ourselves not as chemical machines, but as resonant electrical beings. And if that's really true, well, then we have to seriously consider the consequences of surrounding ourselves with this constant, chaotic storm of artificial electromagnetic fields. It's a perspective that really challenges us to rethink the very nature of health and our relationship with the technology we use every single day.